Hello everyone! In this video series we want to talk about how our quadcopter actually works. So in the first video we talk about the hardware, the sensors we use, how we built our frame and all this stuff. In the second video we show you how we programmed it, so we show you our PID controllers and the control loop. And in the third video we show you the graphical user interface. It's programmed with LabVIEW and it's quite interesting. So let's get started. The brain of the quadcopter is the Colibri T20 module from Toradex. It's a 1 GHz dual-core processor which runs Windows CE 7 on it. Here on the monitor you can see it says Windows CE 7. So this monitor is directly connected to the module. We can actually attach a mouse and a keyboard and all that stuff because it's really like a computer. And our programs we write, we basically just upload it on the operating system and start it from there. So let's show you how the boot process works. So I just plug the power out, and this is powered with battery right now. And so you can see here the module is booting. We have to do this every time, of course, when you start the quadcopter, and now it's done. So actually right now no software is running, but it has an auto-run folder, so we just put our exe file in there and it will run automatically. Now I started our program, so the blue LED is on. This is because no remote control is connected. If you connect the remote control it will turn off, but this signals us the motors are safe, because if you have no remote also the motors will not turn. This board with the LEDs, we've developed this ourselves, and the board below, this is the Iris board. So this is from Toradex, also with the Colibri module on top. The Colibri module only has the processor and the flash memory and all this stuff, but we need the lower board for the power supply and other drivers, also to access the headers and other pins. The motors are A3042S Hacker motors. This is a German manufacturer and they are extremely good. They are very high quality motors and we got them with some discount, especially for this project. We've tried different motors, but these are absolutely the best we had so far. Up here you can also see our remote receiver. This is from Futaba remote control. It's a 35 MHz, it's a bit old, but it still works very well. Now let's screw the top off so we can see underneath. Here you can see our sensor board. We designed this ourselves with Altium Designer. The license we got from the Toradex challenge, and there are different modules on top of it. It's directly connected to the Iris board, so there are 3 headers, one for next to the USB, one for the power, and the big X16 header with 40 pins. And so we can access the UART serial stuff, the I2C connection, GPIOs, so we have all the connections needed for a quadcopter to work. This little guy here, this little black thing, this is the MPU. This is the most important sensor of this project. It houses 3 gyroscopes, 3 accelerometers and 3 compass sensors. It also has a DMP, this is a digital motion processing unit, which already does some of the computation to get a nice angle estimation. Next to it we have the barometer. It has a resolution of about 30 centimeters. Right above is the ULN for the LEDs, so this is just a basic driver, and next to it we have 2 LEDs which signal the power supply. So there is one for 3.3 volt and one for 5 volts. For the motors we use this I2C 2 PWM controller. It's actually an LED controller, but it does the job very well. And it has 16 channels. We actually only need 4, but we have now 12 on the board, so we can add other servos or maybe an LED, RGB LED or something like this. Or build a hexacopter. This is a much higher resolution than the stock PWM controller on the Toradex board. So like there we have 250 steps, and here we have 4000. This blue thing here is the XP controller. This is for the communication between the quadcopter and our computer. The white thing here, this is just a VLAN USB stick, so we can program it wirelessly, because programming works very well over VLAN. The frame of the quadcopter is fully made out of carbon and aluminium parts. We actually bought this frame, but we had to make some adjustments. So this plate here, that is directly holding the aluminium parts. We designed it ourselves and cut it out with a CNC machine, and also the plate above. We had to make some adjustments, so we added dampers, and the module up here, it holds only on those 4 damping thingies. There are different kinds you can buy, so you can get so they are a bit harder or smoother. And this helped a lot. The sensor readings got a lot better when the electronics here was stable and the vibrations didn't go onto the sensors. Down here we have the battery. It's a 3800 milliamps, and we get the flight time of about 15 minutes with it. So this was a short overview about our hardware. Now you might wonder, how do we actually program it? The source code will show you in the next video, but here I can quickly show you how the programming process actually works. This is the graphical user interface. We use it to stop the current program. And here is the Visual Studio. This is our development environment. Here is the whole source code. It's all programmed in C++. And to send it to the quadcopter, we use the USB cable. So this is directly connected to the quadcopter and to the computer. On Visual Studio we can say, hey, it's a Toradex module attached, and then we can say compile and deploy solution. Just this button here. And then it will compile, and in a few seconds it will send it to the quadcopter. In the next video we will show you how our control loop works and how the whole C++ program is set up, because we use multiple threads and we explain you how they work and how we read the sensors and all this stuff. See ya later.